Alright, so this is our review for summative number 3, and we're going to see one repeated section on the summative, and that's the first one here with advanced factoring. So make sure you have your gold factoring flowchart handy, and that's where you're going to find, the process, all the formulas you need, and of course you might want to go back to your last test and make some corrections and see my notes if you had anything wrong. Like all the reviews, I'm going to do pretty much every other question and then leave the rest for you to do, and you can look at the answer key for some help on those intermingled questions. So this first question, 27x to the third plus 8. The top of the flowchart says to look for any common terms, and 27 and 8 do not have any common terms. So then I move down the flowchart, and I realize that we have a special pattern here. It is the sum, because of the plus sign, of cubes. So the pattern that we're going to be using is, right off the flowchart, a plus b times a squared minus ab plus b squared. But part of the pattern that I think some of you forgot last time was you forgot to actually find out who a and b were. So you have to cube root. Remember cube rooting these things? You have to cube root each of these terms. So the cube root of 27x to the third is 3x, and then the cube root of 8 is a 2. If you have to cube root on your calculator, remember you can go to the math menu and then down to number 4. You can also use your factoring flowchart. Those cubic numbers go in order, so you can just count. Alright, here we go. We're going to fill in our a and b into the pattern. And the terms are a plus b, so 3x plus 2. Oops, I meant to make that red. Alright, this part I'm a little scared of. A squared is like 3x times another 3x. Make sure you're squaring both the 3 and the x. So that is a 9x squared. And then minus a times b, so 3x times 2 would be 6x. And then plus b squared, which would be 2 squared, so I'm going to call that a 4. The cubic pattern is awesome because once you use it, you never have to return to that question and factor further. It's always just done. Alright, moving along to number 2. Back to the top of the flowchart. There is definitely a common factor in this question. I don't have my calculator handy, but I do have a key handy. That's helpful. Alright, so they're both divisible by 7, and then they also have a common term of x. So the 7x is something that you're going to take out of the front of the problem, and then when you take out 7x, you're still left with x to the 4th, and then minus 16. Oh man, this is a tricky question. Leave the 7x out in front, but let's talk about this x to the 4th minus 16. That is a special pattern. This pattern right here is the difference of squares pattern. So the way that pattern works is you do a plus b times a minus b, meaning you take the square root of each of them. Now this one's a little tricky, because x to the 4th, when you square root it, it's x squared. And then you have a plus 4 and a minus 4. And if this is where you stop, I have bad news for you. You are not done, because the difference of squares pattern shows up again. Alright, so this is a triple layer factoring question. So the 7x stays in front. The x squared plus 4 is not going to change. You can't factor that one any further, because there's no such thing as the sum of squares without imaginaries. But x squared minus 4 factors into difference of squares again, meaning it's x and x, and then a plus 2 and a minus 2. So that was an incredibly challenging question. A little perseverance on your part there, guys, so be careful. Alright, let's take a look at number 3. There's no common term for the entire problem, but I do notice we have 4 terms, which means we're going to factor by grouping. So grouping means that you group the first 2, and then you do the same thing with the last 2, and you look for common factors. So a common factor in this first group would be a common 4 and an x squared. I think the issue some of us had last time, we just weren't taking a big enough common factor out of the problem. So if you factor out a 4x squared from that first group, you still have an x and a plus 2. And then our common factor for the second group, I see a common 5, but the fact that they both have negative signs leads me to believe that I need to change the signs, because I got to match this parenthesis, right? So let's take out a negative 5. Let's divide everybody by a negative 5. And when you factor out that negative 5, you should end up with x plus 2 again. Remember, the parentheses have to match. So now that you have a common x plus 2, you can take that out of the problem. And then your remaining pieces, 4x squared and then a minus 5, gets written as the other factor. This is another case where you might have to watch out for secondary factoring. Sometimes the thing I just wrote down in red factors again. If you see the difference of two squares show up, which this one was close, right? It is the difference. The first term is squared, but because that last term is not squared, you don't have to follow through with any more factoring, so you can stop that question. Alright, so better luck on advanced factoring this time. And now we have some new stuff. So the first one being the fundamental theorem of algebra, the gigantic theorem, right? How do you determine how many solutions a polynomial has? And the answer is it's the same as the degree, which is, remember, the highest exponent. So there's going to be a question on your test where I give you a polynomial and you're going to tell me, like, up to how many solutions are we going to find? And then write an example of something that has 4 solutions. So, whoa, sorry about that. I didn't mean to. There we go. Okay. So an example of that, 2x to the 4th minus 3x squared plus 1. The reason that this one would have up to 4 solutions is because I look at the highest exponent, which is 4, the degree is 4. Now, what type of solutions are they? Is there any multiplicity? Maybe. But this question will have up to 4 solutions. Alright, so now we're going to execute fundamental theorem. We're going to start with a higher powered polynomial that we cannot factor, or at least I'm not going to ask you to factor it, and you're going to use synthetic division to break it down to a quadratic, and then you're going to find the rest of the answers for me. So first thing you're going to do is use your calculator, and then find all rational zeros, or find a rational zero. So you're going to type this into y1, and you're going to look at the graph. And I don't know exactly what the graph looks like, but one thing for sure I can tell you is that something happens right here. The graph crosses the x-axis at x equals 1. So that's the one you're going to write down in that line. That is also the x value that you're going to use in synthetic division. So you're going to use that over here, put 1 in the box, and then you're going to line up your coefficients to the original polynomial. So the coefficients, remember, are 1, -1, 25, and -25. Alright, so remember synthetic division. I kind of wish that section was earlier in the test, then we could have practiced it, but oh well. You start by bringing down your first coefficient, and then you multiply when you're on the bottom. So 1 times 1 is 1. And then you add them up, and you get 0. 0 times 1 is 0. And when you add those up, you get 25. And then 25 times 1 is 25. And you should always get a remainder of 0 right here. Okay, this remainder better come out to 0 for a fundamental theorem, otherwise you've messed up. So now we need to take these coefficients and put them with the actual polynomial pieces. So remember, you guys started with x to the 3rd, which means this is now knocked down 1 level. It's going to be x squared plus no x is plus 25. So we're going to write it as x squared plus 25, and they want you to solve them. So this is this last question. Find the imaginary, notice it says imaginary, so you should be getting I's, solutions. You're going to solve that by first subtracting 25 over. So we end up with x squared, equals -25. And then when you square root both sides, you get x equals, this is where the plus or minus will show up, and then the square root of 25 is a perfect square, and if you separate it from the -1, you're going to remember that that is a 5 and an I. So I'm fine if you just write x equals plus and minus 5i, because those are the two solutions. And then if you join them up with the original solution from your calculator, that's where you're getting your 3 solutions. So 1, 2, 3 solutions. Alright, so a little messy there. I apologize for my scribbles everywhere. Go ahead and practice this one as well. If you check the key, like let's say you're at home and you don't have a graphing calculator, when you graph this in the calculator, you're going to find out that there is a solution at x equals -5, and that should get you going on the rest of the question. Alright, so now this you do need a graphing calculator for. When I look through my two questions here, they're both equally kind of fun. I am going to do 6a with you, which means we're going to get to our calculator, and I'm going to pause the video, and you pause your video as well. If you have a graphing calculator or an emulator, you need to type this guy into Y1, and then go ahead and get a standard viewing window, a zoom 10, for an appropriate window. Alright, so once I had my function typed into Y1 and I approached it with a standard viewing window, I get this cubic. When I go back to my paper, they want me to find all of the zeros, and apparently there's 3 of them, which I saw. And write yourself a big note, and keeping this in mind on the test as well. I want you to round to the 100th place, which is like 2 decimal points, okay? So no like estimation through, you know, it's about 5. No, I need like 5.02, whatever it is. Alright, so let's go find our x-intercepts, our zeros, and you have to remind yourself how you find these on your calculator. You're going to go to the calc menu, which is second trace, and then you're going to choose number 2, the zero finder. So on my calculator, I notice there's 3 zeros. This one right here is, you know, not quite to -1, so it's about -0.6, I'm going to make a guess. But I need to find it on the calculator more accurately. So second trace, and then choose number 2, the zero finder. And then when it says left bound, you need to get your cursor so it happens before the intercept. So a number that's before the intercept would be like -1. That would be to the left of it. I have to hop, mine's really slow. And then now I need a number after the intercept. I'm going to go with 0. It's definitely after. And then when it hits a guess, you can actually type in your guess of -0.6, or you can just hit enter. Pretty good guess in Abruzzo. If I round to the 100th place, that's -0.63, 0. So, first ordered pair, -0.63, 0. Alright, we got to do that all over again for the other 2 intercepts. I can tell from my calculator, an estimation, this is about 1. So, when I do this again, second trace, number 2, something before that would be a 0. Something after it would be a 2. And then enter for the last guess. Yeah, pretty good. So 1.12, 0. Where'd you go, paper? Alright, 1.12. And then same process for that last one. I'm going to save myself a little time. It's at, oh no I'm not, because I didn't round the right way. Darn it. Alright, so second trace, it's about 3.5, so keep that in mind when we make our guesses. Something before 3.5 would be a 3. Something after 3.5 would be a 4. And then in the middle there is pretty good guessing. 3.51. Remember, anytime this e with a negative exponent comes up, that just means 0, so don't get freaked out by that. So 3.51, 0. Alright, so those are all in the calculator. When you go to find your max and your min, which this graph had both a maximum and a minimum, you're going to go back to the second trace menu. And then you're going to choose either number 3 or number 4, depending on whether you were looking at a maximum or a minimum. So, back to my calculator. I'm going to find that maximum first, which is this guy here. He's about at x equals 0, so we're going to keep that in mind when we make our guesses. So this time I'm choosing a maximum, so number 4. You need to get your cursor so that it's before the maximum, so I'm going to go -1. Hoppin'. And then after the maximum, I'm going to go to 1, definitely after. And then hit enter for the guess. You don't even have to type in your guess. This time I need you to write the whole ordered pair rounded to the 100th place for both. So 0.13, 5.13. 0.13, 5.13. And then similarly, you're going to find the minimum using the minimum finder. So, let me get rid of that ink. This minimum, let's see, it's about at 2.5. So I'm going to keep that in mind when I estimate. So second trace, this time it's a minimum. All right, something before 2.5, I'm going to go with 2. And then something after 2.5, I'm going to go with 3. And then enter. 2.53, comma, negative 8.76. 2.53, negative 8.76. I'm going to forget that. 2.53, comma, negative 8.76, maybe? Oh man, I can't remember. All right, well, if that wasn't right, I apologize. All right, now I notice on my key I rounded to the 10th place. That was my bad. Make sure you're rounding to the 100th. All right, so the next part's kind of tricky, so I'm not going to do that one quite yet. Good news is we're done with our calculator. I can transfer all this over to my graph. Unfortunately for me, I don't really graph very well, so best wishes to you. You're about to witness one of the world's ugliest graphs. All right. 0.13, 5 point, you know, like here. And then 2 something down to negative, almost negative 9. Yeah, about there. All right, so you have, I feel like I need to concentrate when I draw this. Oh man, okay, so I missed. What to do? It kind of looks like that. I mean, it's not the greatest drawing. It's not the worst I've done though. For this next part, I'm concerned that we might mess it up if I try to draw on my picture itself. So when they ask you for increasing and decreasing, these are domain intervals. Which mean you're only allowed to look at the x values of where your roller coaster, remember, is turning around from increasing to decreasing. So I think it really helps if you go to your max and min and you highlight the x value, which is the time where your roller coaster turns around, right? So like this right here is a time when it turns around, and this right here is a time when it turns around. The other thing that I really love when you guys do this is you draw yourself a different picture over here. Just draw the roller coaster track. Oops, that's not helpful. Just draw the roller coaster track. And in fact, you don't even have to put the arrows on it. And it doesn't even have to look like the actual roller coaster track. That's not important. Okay. These turning points of the roller coaster are those x values. So this guy was 0.13. And this guy was 2.53. No, that's not 2. Okay, 2.53. So when they ask me about increasing roller coaster track, that would be this part of the track, and then it starts increasing over here as well. So it's increasing. This is a little tricky. It starts forever. So negative infinity, and then it stops increasing at 0.13. Which I like parentheses on that now. And then there's another part of the roller coaster that's increasing from 2.53 and then forever. It just keeps increasing forever after that. For decreasing behavior, that's the downhill roller coaster part. That would be from here to here. So 0.13 to 2.53. That is a super tricky question, guys. Those are tough, so please, please practice that. And then end behavior, it's that template again, but this time I took away half the template from you, so you're going to have to know how to fill in these parts first. When I ask you about end behavior, I'm referring to the left and the right end behavior. So x goes to the left would be x goes to negative infinity, and x goes to the right would be x equals positive infinity. So you are going to have to fill out that part as well. And now when you look at your roller coaster, if I look on the left side, it's going down, 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 down to negative infinity. And if I look at the right side, it's going up, 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 up to positive infinity. So you are responsible for almost the entirety of your end behavior template this time. I took away that one little step at the end. You're going to have to figure that out. All right? Those are nasty questions. The good news is there's only one of them on the test, so make it count. There's another one for you to practice. If you don't have a graphing calculator, just go ahead and take the points from these 3 parts here and the sketch from my key, and then could you try to do the increasing, decreasing, and end behavior without looking at the key? That would be really important. All right, and then the last 2 sections, we have long and synthetic division. So I'm going to move this over a little bit. I'm going to do number 9. And I'm looking at a long division question, which means my dividend here, 3v squared minus 31v plus 67 is being divided by v minus 7, the divisor. Now, I like when the divisor has parentheses around it. And then to remind you of our steps, step 1 is to divide. Step 2 is to multiply. Step 3 is to subtract. And then step 4 is to bring down. And then you keep repeating that process until you're out of terms. We might have a remainder, we might not. Alright, so step 1, divide. You take your lead term and divide it by your divisor's lead term. So you have 3v squared divided by v, which is 3v. So that's part of your answer, and it goes up here. And now you multiply. So the 3v gets multiplied into the divisor. I think it would help if you do that work over here on the side. So 3v times v minus 7. Kind of think about what that is. That would be 3v squared minus 21v. So that distribution is what gets written up here in our work. So 3v squared minus 21v. Now I really encourage you guys to use a color right here on this step, parentheses around that thing, and let's subtract. The lead terms are gone, they cancel, and then negative 31 minus a minus 21 is like plus 21. So that's a negative 10v. And then step 4 is you bring it down. The next term, which is our last term, so we're almost done, plus 67. Alright, now we start all over again. Now we have a negative 10v being divided by v. So negative 10v divided by v is negative 10. That's part of your answer. So now this negative 10 gets distributed in. I think it would really help some of you if you wrote that right here. So negative 10 times v minus 7, which is negative 10v plus 70. So what we just wrote down goes up here in your work. And then if you have a color, I think this is a great time to use it, you're going to subtract all that. Negative 10 minus 10 cancels. 67 minus 70 is negative 3. So this last number here, this is the remainder. So then when we go to write our answer down, our answer is 3v minus 10, and then the remainder of negative 3, you can say plus negative 3 over v minus 7, or most of you just write a subtraction sign of subtract 3 over v minus 7. And that is your full quotient with the remainder as a fraction. That's what I'm hoping to see on your question. Alright, so I think there's another one for you to practice, so please do. And now there's a synthetic. So you must have the proper method during each section. Someone asked me if they could check their work by doing synthetic on the long division one, and I said sure. But I don't know if you need to do that much work, or maybe you won't have time to do that much work, so be careful. So remember, in the box, you come up with the solution to your divisor first, which would be k equals 6. So that goes right there. And then watch your terms here. Oh, you know what? I need to back up a minute. I feel like... Oh yeah, that one's fine. There's a missing term. It goes from 4th degree to 2nd degree. So like right here, there's 0k to the thirds. So that was tricky. You got to make sure you put a placeholder there. So you have a 1, you have a 0, you have a negative 36, you have an 8, and you have a negative 48. So we're going to start the problem by bringing down our first coefficient of 1. And if you're below the line, you multiply, and if you're above the line, you add. Alright, 1 times 6 is 6. Add them up. 0 plus 6 is 6. 6 times 6 is 36. If you add those up, you get 0. 0 times 6 is 0. And then 8 plus 0 is 8. And then 8 times 6 is 48. Add them up, you get nothing. Now, this last number here, it doesn't have to be 0 for the remainder on these questions. The remainder could be anything. But I think the way I set it up was I'm going to give you a couple questions to practice. One of them might have no remainder, but there's a missing coefficient, and maybe the next question doesn't have any missing coefficients, but there is a remainder. So we're just trying to cover all of our bases, right? So the quotient has these coefficients, and it's k to the 4th was being divided by k, so that means this first term here must be a k to the third. So your quotient is k to the third plus 6k squared. You can say plus 0k if you want, and then plus 8. No remainder, so you don't have to do that fraction thing. Alright, and then one more, I think number 13, and then we're done? Yeah. So, again, the solution to the divisor goes in the box, so that would be x equals 8. This time, you do not have any missing terms, quadratic, linear, constant. So 3, negative 19, and negative 43. So bringing down the 3. Now it's a series of multiply when you're on the bottom and add when you're on the top. Alright, 3 times 8 is 24. Negative 19 plus 24 is 5. 5 times 8 is 40. And then negative 43 plus 40 is negative 3. Now, that last number you just got, that is the remainder. So now this is a bit tricky because you got to remember how you write your answer. So, you had, remember, 3x squared and you divided by an x. So if you think about your lead terms, you would be left with a 3x as your first term. So this 3 is really a 3x plus 5. And then I'm okay if you say plus a negative 3 over the x minus 8. But most humans say 3x plus 5, and then instead of plus minus, they just make that a subtraction. And that's the final answer they give me. So, frankly, I'll take either one of those answers, guys. I don't really mind. Didn't like how big that went. Covered up my minus sign. There we go. Okay, so that's going to be your test. The calculator work obviously is going to be a bit of a challenge for us because, you know, some of you don't have the option to practice at home with it. So you really want to use your class time wisely. Coming in for help and maybe during advisory time just to use my calculators is totally fine. Coming in for help before and after school, though, is critical. And then surely this is not the last time we're going to talk about graph and calculator work as far as our curriculum. But I'm hoping that you guys have the basics covered and we don't have to test any of these again. That would be fantastic. All right, good luck.